There we go. All right. So we're going to simplify these radicals. The way we're doing that is we're looking for perfect squares that are inside the number underneath. So if we look at, I'm going to start with B just because it's less annoying. 24. I could write this as 4 times 6 because 24 is the same thing as 4 times 6, right? I like that because I know the square root of 4, and I know that 6 is only made up of 2 and 3, so it's not really going to simplify. So this we can write as square root of 4 is 2, square root of 6. That's the way we do it by hand. And that's our simplified answer. We can also check it by going to our very, very bestest friend, the yellow calculator. And we can do the square root of 24. And it'll give us 2 square root of 6. It'll simplify it for us. So the yellow calculator is going to be a very, very lovely friend of ours. Because something like 122, ooh, that's not a pen. It's kind of annoying because I'm like, I don't know what that divides into off the top of my head. But I know it divides by 2 because it's even. And if we type that in our calculator, it's 61. Does 61 divide by anything? Nah. 61 is actually a prime number. So that is fully simplified, which means as a simplified radical, this is exactly what we were given.
So don't do nothing to it.
It doesn't do anything to it. We tried. And we can always double check it. When we get something like that, we'll always get a little extra concerned. If we go square root of 122 in the yellow calculator, it spits back square root of 122. We know it simplified before. So the fact that it didn't simplify this tells us that this is simplified. So this is called whoever wrote the bell work is a little bit of a jerk. It was honestly probably me. All right, so then the last one up here, square root of negative 49. We can't just type in the calculator. If I type in square root of negative 49, we're going to get an error. Because calculators only work with real numbers. So we have to go old school on this one again. And we're going to do the square root. And I'm going to put this as negative 1 times 49. Because I don't hate the number 49. That one's totally fine. Because square root of negative 1 times the square root of 49 we can do. What is the square root of 49?
7.
7. What do we call the square root of negative 1? I. So this is I times 7 or 7I, just because I times 7 sounds weird. Nope, that's not the highlighter. And so this is our answer. So we are going to have these come up next week again. So remembering how to do radicals is going to be one of those things. For part B, we're doing some substitution here. We're going to use this. Oh, that's not what I meant. This expression. And we are going to substitute in an A of 5, a B of negative 2, and a C of 7. And we're just going to substitute those in. So what I have is B squared, so negative 2 squared, minus 4 times an A of 5 times a C of 7. And we're going to write it out first. And then we're going to simplify this, which we can do by hand. Or we can go in the calculator. And it's going to be negative 2 squared minus 4 times 5 times 7. And we can just write it in straight like that. Boom shakalaka. Negative 136. So this one simplifies down to be negative 136. We are going to be using statements like this on Monday. A bunch. Okay. So today I'm going to show you a different way to do exactly what we did yesterday. That's a little less calculatory. It's a little less cerebral. And then Monday we'll work with these square roots and stuff with the quadratic formula. Alrighty? So, yeah, that's the bell work for the week. So you can turn your bell work page in today. And we're going to get into notes. You're a good friend. Okay, so what we're going to be doing today is we are going to be switching things around into vertex form or our transformation form. That's our ax minus h squared plus k. That guy, we used it a bunch before fall break. We graphed with it. We described some transformations. And what we're going to do is we are going to put standard form equations into vertex form. And we have two options for that. We can complete the square. That's what we did yesterday. Or we can find the vertex using our axis of symmetry formula that x equals the opposite of b over 2a. That gives us the h value, and then use substitution. For our k value. So these are our options on how to get into vertex or transformation form. We can use complete the square to help us find this part. And then if we make it equal 0, it'll scooch what equals on the other side to be our transformation form. So we're going to do 1 with complete the square, and I'll do 2 with the what feels like a shortcut. Because yesterday we didn't do anything that had a number in front of my x squared. Oh, yeah, I can go back. Absolutely. Totally fine. I can always do that. So we're going to do a complete the square that has this number in front. So first thing I need to do is I need to get this constant number scooched to the other side. I don't like it being here. we're also going to switch this y out to be a 0. So we're going to have 0 equals negative x squared minus 12x minus 9. And we're going to add 9 to both sides to get 9 equals minus x squared minus 12x. Tamari, poke Jordan. And normally we'd hop straight into our what squares to make this. Only problem is since it's negative, nothing squares to make this. So what we're going to do is we're going to pull out a negative 1 as a GCF. Ooh, that's the wrong pen. So I'm going to take 9 equals, and I'm going to put negative 1 out front. X squared plus 12x. And I'm going to leave us our gap here. Since my x squared had that minus 1 in front, I want to divide that out because I can't find something that squares to make negative x squared. That's not real. So we're going to put the x squared as a positive so that I can make this be a perfect square. And that's what we're going to do next. We're going to say plus what makes this a perfect square. We know this guy is our x squared. Because that's part of the complete the square stuff.
So you can just cross it out.
Yeah. Yes, Joe. 36. Because we know this is something squared. Remember this guy from yesterday? And the middle term is 2 times the front guy times the back guy. So question mark is 6, so we need to add 36 here. But I can't just change my equation. So we're going to add 36 to the other side. But we also need to remember that this 36 is also times this minus 1. So we're going to take our 36 times the number that's out in front. This is this minus 1 because it's still a part of that. Since it's got something multiplied to it, we got to pay attention to it. So what we have on the left side is 9 minus 36. And on the right side, I have my minus 1 x plus 6 squared. Because we added our 36 to both sides. But this 36 is times minus 1. So when I add this 36, it also has to be times minus 1. Because of this number out in front. I added 36 inside. So if I was to undistribute this, I'd have to multiply that guy by negative 1. So let's simplify the left side. 9 minus 36 is what? Negative 27 equals this hot mess. And if we were solving this, we would divide and square root and blah, 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 blah. But we're just trying to put it in transformation form. So I want to get that 27 actually back to the other side. Because I want this to be equals to 0 now. Negative 1 x plus 6 squared plus 27. And just like I did up here where I switched to p as 0 to make my life easier, I can switch it back to get my transformation form. I have my A, H, and K. So I could find my vertex. I could find my transformation forms. How this has been reflected across the x-axis. Shifted 6 left, 27 up. Those guys that we did right before fall break. This is a lot. And I know this is really, really calculatory. But it puts it into that transformation form. We could absolutely still solve it there. Like, we could still go back to this line and solve it and find our solutions, our roots, our zeros, our x-intercepts. But we hadn't done one that had a number out here before with the complete the square. So I wanted us to see one like that. But honestly, I think this is the harder way to do this. So what I'm going to do is I'm going to show you a shortcut, which is to go through the vertex. Because we have found the vertex before. We did that during fall break for like a week. We found that vertex. So we're going to practice this again with a different equation. X squared minus 8x minus 65 equals 0. And what we're going to do this time is we're going to do this with our axis of symmetry. That was what I gave as our option number 2. Where we are going to find our axis of symmetry. We used to call this AOS. Opposite of B over 2A. So our X equals the opposite of, what's our B value? -8. So the opposite of -8 over 2 times our A. What's our A value? 1. So what is the opposite of -8? 8. 2 times 1? What's 8 divided by 2? 4. That tells me in my vertex, that's a T, the X value is 4. That's my H. My H is going to be 4. To find my Y value, what we're going to do is we're going to take that 4 and substitute it in place of my X. Ooh, that's not it. So my Y equals 4 squared minus 8 times 4 minus 65. And we're going to type that in the calculator. So we're going to have 4 squared minus 8 times 4 minus 65. I think I did that right. Yeah. And we should get -81. So my vertex is at 4, -81. That's my K. What's up?
81.
Yep.
So you gotta go 4 to the right, up or down 81.
And down 81 would have been our transformation. So that's why we're not graphing it. But I can put this into my vertex form. I have the vertex. If we know it's going to be AX minus H squared plus K, I know my H, X minus my H of 4, plus K plus -81, so minus 81. And what's my A value? 1. It's the same A value as in my standard form. So I can put it into vertex form here. So you don't have to complete the square to get it into vertex form. I could even come through and solve this from here. Just like we did yesterday where we have our y be 0. X minus 4 squared minus 81. Add 81 to both sides. And we could solve it this way just by using our square root properties here. You don't have to complete the squares to get there. We could do this, square root both sides, and get down into solutions. We can do that. Even without completing the square, we could absolutely get to solutions here. It's just what we did yesterday. So this gives us another option to do the same exact thing as complete the square. We just have to show you complete the square. Okay, so we're going to do one more with our axis of symmetry. Because complete the square is not that bad when a equals 1. Like, it's not. We'd get the same thing where we have to figure out what number would make this guy a perfect square. We could do that. But when a is not 1, it's a lot harder for completing the square. Like that first one that we did today. When a is not 1, completing the square is a pain in the butt. So when your a is not 1, I do recommend doing our vertex form, where we're going to find our x value for our vertex using our axis of symmetry, which is the opposite of b over 2a. So we're going to have the opposite of, what's our b value? Negative 12 over 2 times our a, which is what? 3. So the opposite of negative 12, that's positive 12. 2 times 3 gives us 6. So 12 divided by 6 is 2. So in my vertex, the x is 2. I don't know the y yet, but I know the x. To find our y value in the vertex, we take our equation and we're substituting in that x value. 3 times 2 squared minus 12 times 2. That's what I'm putting in there still, plus 5. He's just not involved in the axis of symmetry. So what we're going to do to figure that out calculatorily is in the calculator. 3 times 2 squared minus 12 times 2 plus 5. And you can just type the whole darn thing in like this. And it's going to spit out negative 7. Negative 7, wrong color. Y equals negative 7. Again, this is my H. This is my K. And we know our A. We used it in our axis of symmetry. It's that guy. I know A, I know H, I know K. I can write it into my vertex form. Y equals A x minus H squared plus K. So Y equals, what's our A value? 3. X minus our H, what's our H? Our H is positive 2, but it's x minus 2. Squared plus K plus negative 7, so minus 7. From here, I could identify my transformations. It has a vertical stretch. It's been moved right 2 and down 7. I could add 7 to both sides and divide by 3 to solve with square roots. I could graph this thing. I can do all kinds of stuff with this guy in transformation form. I could graph it from standard form with my axis of symmetry and my y-intercept of 5. So we have a lot of information about this parabola without ever drawing a graph. I have my vertex. I know which way it opens. I know that it's been stretched. I know it has a y-intercept of 5 because that's our c. Our c value is always our y-intercept. That's this guy here. That's our y-intercept. So we have a lot of information even without a graph. It's just looking at things in a different way. Okay? So you guys have a solid 10 minutes, closer to 15, to work on homework 3-5. I'm not giving you a new homework today. Same one as yesterday, because I know these complete the squares take some time. So use this time, turn in the bell work today if you didn't turn it in yet. Our quiz is next Friday. We're going to have notes Monday, Tuesday, possibly Wednesday, but maybe not. We'll see how it goes. And then reviewing and quiz Friday. Yes, dear. Yes, dear.